So when we want to identify rational and irrational numbers, here's a good sheet to kind of help you differentiate between the two. I will tell you that just kidding. I do want to keep I for irrational. It's this one. I don't want to use the R. I want to use the letter Q, which is how we identify rationals. Rational numbers and irrational numbers together make up the real number system. And for that, we use the R. That's the bigger deal. So it takes precedence for letters. We use the letter Q because I like to think that it represents quotient, which is what a rational number is. So let's go through some of these and let's see what we know. I know that this is irrational. And I know this is irrational because it has the pi symbol. 42 is rational. It's a whole number. 75.082106 repeating, that will be a rational number. I want the square root of 101. If I were to put that into a calculator, I would get a whole bunch of decimals, and they would be non-repeating, non-terminating decimals. So that's irrational. Again, a repeating decimal, rational. A fraction, rational. Pi, irrational. 5.6213, that's a repeating decimal, rational. Fraction, whole number. This is non-repeating. And non-terminating. I don't know what the next digit will be. And so because I don't know what the next digit is going to be, this is irrational. The square root of 17. I know the square root of 16 is 4, but the square root of 17, I'm gonna get a whole bunch of decimals. If you don't believe me, let's actually look at it. I have my handy TI calculator right here. And so I want to find the square root of 17. This is just a set of some of the decimals behind here. I don't know what else could go there. I don't know what the next number is going to be. So this is going to be irrational. Again, I see ellipses. This means it's non-terminating. I do not see a repeating bar. So that means that it's also non-repeating. So it's irrational. The square root of 64 is 8. Rational. 1/4. Rational. My bad. Square root of 25 is 5. That's rational. Repeating decimal, rational. Fraction is rational. Oh, here we go again. This is irrational. Terminating decimal. So let's go in and make a list of everything we know that's rational. In order to be a rational number, what did we choose? Let's see. We looked at whole numbers. I'm actually going to extend this. It's whole numbers and their opposites. Whole numbers and their opposites together make the term integers. Okay. What else do we have? Repeating decimals. Now, you did this last year in 8th grade where you turned a repeating decimal into a fraction. My favorite word, fractions. What else did we have? Square roots of squares. All right. So I'm actually going to make this number 1. Integers, that's a whole number, it's opposite, and 0, because 0 is a whole number. Repeating decimals, fractions, square roots of squares. And I think that covers everything. Oh, this one right here, that's a terminating decimal. So a terminating decimal is rational as well. Let's look at our irrational numbers. Okay, first type I saw was right here. Special numbers. Pi. Down the road in Algebra 2, you're going to talk about E. That's a special number. It's irrational. Right here, we have square roots of non-squares. And then we have this one, non-repeating. And non-terminating decimals. And that's everything you need to know about identifying rational and irrational numbers. If we wanted to do this, I could, and I think about all the different possibilities. This is a terminating decimal. It's rational. This is a fraction. It's rational. The square root of 64, I feel like we just did that, is 8. Rational. 0 is a whole number. Rational. Square root of 75. 75 is not a square. Therefore, this is irrational. Here, we'll do this. 6 2/7, it's a fraction. The square root of 32, whoa there, robes. That's irrational. 32 is not a square. Negative 19 is an integer. Therefore, it is rational. 12.67, oh, there's a repeating bar. I know that this 7 is going to repeat. Therefore, this is rational. My other 8th grade math teacher who taught with me, the way she described it to her students was, if you have a decimal number and you can predict the next decimal number, then it's rational. I know the next number is going to be 7, and the one after that is going to be 7, and the one after that is going to be 7. That's rational. Square root of 121 is 11. Rational. The negative of the square root of 100 is negative 10. Negative number, integer, rational. Oh, shoot, I did that wrong. This is square root of 121. 12/5 is a fraction. Rational. We said this was rational. Okay, 2.343443, Yeah, it looks like it could be a pattern, but I don't know that for sure. I could change my mind and make this like 5. We don't know what the next number could be. It could change at any moment. There is no guarantee that it will follow that pattern. As a result, it is a non-repeating, non-terminating decimal, and therefore this number is irrational. It's because of these ellipses. Had that not been there, we'd have moved it to rational. And pi is also irrational. And then you've got to take a minute and make sure you understand it. Make sure you know what goes where. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All right, I've accounted for every number. So look at the differences there. Square roots of squares, terminating decimals, fractions, repeating decimals, whole number, integer, square roots of squares, irrational numbers, square roots of non-squares, non-repeating, non-terminating decimals, special values. All right, let's number these. And this is so 8th grade, but it's always such a good review, especially at the beginning like this. All right, 0.75, that is just before 1. So here's 1/2, and then we go in between, there's 1/3. So let's call this point A. All right, square root of 3. I'm going to need my calculator. Square root of 3 is about 1.73. I'm going to put this here. It's about equal to. It doesn't exactly equal, but it's about. I know this is 3. So let's knock these two out. 1.73 is, there's 1.5, there's 1.75, so it's just before that. Square root of 9 is 3. It's right here. Negative 2.5. Here's 0, negative 1, negative 2, negative 2.5. Oh, negative 15/10 is negative 3/2. Or some of you might look at it as negative 1 1/2. Negative 1, negative 1 1/2. 2.6 repeating is after 2.5, but not quite 2 3/4. So we'll put this here. Negative square root of 2 is about, let's see, the square root of 2 is 1.41. So this is going to go, oh, there's negative 1.5. This goes just before it. And then pi is about 3.14. So it's a little after 3. So there's your review of 8th grade math. What's a rational number? What is an irrational number? How can we tell the difference? How do we place them on a number line? There is a standard for 9th grade that specifically says, know that the product of a rational and an irrational, blah, blah, blah. Know that the sum of a rational and irrational is blah, blah, blah. So that's what I want to go over next. So you can identify them individually. What happens when you do math on them? Think about this. 5 is rational. 1/79th is rational. So if both of these are rational, our final answer will also be rational. So I know that number 1 is rational. Number 2, what's the square root of 1? 1. That's a whole number. That's an integer. It's rational. The square root of 7 is irrational. Okay? What happens when you add a rational number to an irrational number? You get irrational. In most cases, and I have to say that, anytime you throw an irrational number into the mix, you will get an irrational. There are a couple of cases where it won't work. It's none of these. Well, number 6 will do it, but I'll show you a few others. Okay. The square root of 3 is irrational. 1.7349 is irrational. When you add irrational numbers, you get an irrational sum. I guess I can show you the exception over here. You're going to like this. I love to look for exceptions. Most teenagers always like to find some loophole. Here's one. Let's take the square root of 3 plus the negative square root of 3. What happens when you add a number to its opposite? You get 0. And that, my friend, is rational. That's one of the only cases where that happens, is if they zero out or you multiply reciprocals. And when you multiply reciprocals, you get 1 as an answer. All right, let's look at this one. This is really 1/9. I remember that from 8th grade. This is really 3/9, also known as 1/3. So they're both rational. When you add rational to rational, you get rational. The square root of 4, rational, it equals 2. This madness with the ellipses, non-repeating, non-terminating, is irrational. So when we add those, we get an irrational sum. All right, one of my favorite problems is number 6. There's a rule that says when you do this math and you're multiplying radicals, you can actually put them under the same radical as long as they have the same index. So since they're both square roots, I can combine them. So now what I'm really doing is finding the square root of 16. The square root of 16 is 4. So that's rational. All right. We have irrational here. When we multiply, square root of 9 is 3. That's rational. Our final answer, irrational. When you multiply rational times irrational, in most cases, you will get an irrational answer. And then this last one, repeating decimals, remember, are rational. So when we multiply rational times rational, we get rational. Think about it. When you multiply a fraction times a fraction, in most cases, you get a fraction. All right. I can show you an exception for this one as well. Let's take the square root of 7 times 1 divided by the square root of 7. What happens here? Well, you would get the square root of 7 divided by the square root of 7, and that equals 1. So those are your two main exceptions. But the key to remember is whenever we're multiplying by an irrational number or adding, in most cases, the result will be irrational. So make sure you know what happens when you operate on rational and irrational, and make sure you can identify what is rational and irrational. And that's pretty much your first lesson.